This problem is 4.3, number 11. It's a mixture problem. A tank contains 100 kilograms of salt and 2,000 liters of water. A solution of a concentration of 0.025 kilograms of salt per liter enters the tank at a rate of 10 liters per minute. And the solution is mixed and drained from the tank at the same rate. So the approach to this, and this one, I've already, the student already got these answers correct, but I wanted to work the process out with you. So essentially we're looking at, if we do the amount for A for the amount, we're looking at dA dt is equal to the rate in minus the rate out. So the rate out is a little bit tougher to get. Now the rate in is given to us. They tell us that, okay, we have 0.25 kilograms per liter, and it comes in at 10 liters per minute. So 0.025 kilograms per liter, here's our dimensional analysis, times 10 liters per minute. We have liters canceling, and we end up with 0.25 kilograms per minute of salt coming into the tank. So that means that we're at 0.25 coming in. Now we talk about what's going out. Well, there's an initial amount here that we see that, we have this 100 kilograms, 2,000 liters. I mean, that's our initial amount is going to be 100 kilograms divided by 2,000 liters is going to be 0.05 kilograms per liter, which is what we have here. But as this other salt comes in, it is diluting it because it's not as concentrated, so it's going to make it less concentrated, and that's going to change every moment. So in that case, we could think of it as the current amount, if A is the amount that we have, divided by the volume of the tank. So we have the amount coming in here, then we have the amount that's, so the same amount, same flow rate in and out. It doesn't talk about a change in volume. Excuse me. So we want to try to come up with a fraction here, and so 0.25 is going to be 500 over 2,000. Oh, I missed one step. Sorry about that. So forgot. I mentioned it. I didn't write it down. So it's flowing though at 10 liters per minute, and this is A kilograms per 2,000 liters. So our liters cancel, and we end up with 0.25 minus A over 200. That's what I was going after. Sorry about that. And to get these the same denominator, we end up with 50 over 200 minus A over 200 gives us 50 minus A over 200. So if our differential equation dA dt is 50 minus A over 200, I can separate that out by multiplying both sides by 50 minus A, or 1 over 50 minus A, excuse me. So then that cancels there, and we have 1 over 50 minus A dA equals 1 over 200 dt, and we look at the integral. 1 over 50 minus A dA equals the integral of 1 over 200 dt, or you could put that out front, but we end up with the negative natural log of the absolute value of 50 minus A, and negative because you have a minus A, and that derivative would have been a -1, so that's where that comes from, equals t over 200 plus some c1. So now we can make both sides powers of e to cancel out the natural log. Actually, let me clear out that fraction first. So if I multiply, or I'll just, for the sake of making this easier like that, we have the natural log of the absolute value of 50 minus a equals negative t over 200 plus some c2, which doesn't matter, just it absorbs the negative and becomes c2. And now if we say e to the natural log of the absolute value of 50 minus a is e to the negative t over 200 plus c2, that part cancels, and it means 50 minus a equals e to the negative t over 200 e to the c2. So this we'll just call c. And I will subtract 50 from both sides. So negative a equals c e to the negative t over 200 minus 50, or again, divide by negative 1. I'll multiply by negative 1 this time. Wouldn't that be? We'll mix it up a little bit. And we have a of t is going to be 50 minus c e to the negative t divided by 200. Okay, so we have our equation. We have an initial condition that wasn't overtly stated, but it's stated up here, that we start off with 100 kilograms for 2,000 liters, and we actually found that being 0.05. So we know that our initial concentration is 100 kilograms. So A sub 0 equals 100. So that means A of 0 is 50 minus c e to the negative t divided by 200. And that's supposed to equal 100. So I'll subtract the 50 from both sides. And negative c, some of you are probably screaming at the screen right now, hey, you forgot that t is now a 0. You are right. There we go. So it's negative c times e to the 0, which we all know and love that to be 1, equals 50. So c must be negative 50. So our formula is a of t equals 50, and it's minus c, so we've got double negative here, so plus 50 e to the negative t over 200. So there's our formula. They didn't ask for the formula, but there it is. And then they want us to know, they want us to answer the question. Scroll back up here. Find the amount after 5 hours. So notice this was in minutes. So 5 hours equals 300 minutes. So the amount after 300 is going to be 50 plus 50 e to the negative 300 over 200. I don't like how this is kind of a messy a. Come on, erase. There we go. And we end up with 61.1565 kilograms. Okay, that's the answer to that second part. Go back up to here. Okay. The last part, find the concentration of salt in the solution in the tank as time approaches infinity. So if we take this formula and say the limit as t goes to infinity of 50 plus 50 e to the negative t over 200, we get 50 plus 50, I'll write it this way, over e to the t divided by 200. Oh, but what is our t? Our t is infinity at this point. So we have 50 plus 50 over an e to the infinity, infinity over 200 is still infinity, e to the infinity is infinity. So this second term is just 0, and we end up with 50 out of this. So 50 divided by, our tank was, I believe, 2,000? Yes. Sorry to make you dizzy there. 50 divided by 2,000 is going to be 0.025, which would make sense, kilograms per liter. Which makes sense because if this is the mixture coming in, eventually it'll get down to that level. Some would say it would never actually be there. It'd get infinitely close, but never actually get there. But that's why the last answer is 0.025. Okay, I know this is a longer video, but it's a little more complicated problem, so I hope that's okay. I know that some people prefer 30-second videos, but that's not always 30 second. That's not always possible. Okay, hope this helps.